work today and tomorrow on how to simplify different types of square roots. For example, square root of 25. 5. Okay. 5 times 5 is 25. What other number times itself would make 25? Plus or minus 5. The square root tells you what number times itself makes that given value. 5 times 5 is 25. Negative 5 times negative 5 is 25. So the square root of 25 is both plus and minus 5. $25 is pretty easy. You all said 25 was 5 because 25 is what's called a perfect square. Simplifying square roots, so long as they're perfect squares, is pretty straightforward. Let's make a list of perfect squares to have in our back pocket, because we'll need these when we look at other types of radicals. Perfect square, multiply a number times itself. For example, what's 1 times 1? 1. 2 times 2? 9, 16.
25, 36, 49, 60.
And we can just keep going. There's at least a good start. What about numbers that aren't perfect? On the calculator, everyone right now, type the square root of 72. Square roots of 72, what do you get? Second that. Give me just a second. Square root of 72 is about what number?
Yeah.
8.5, yada, 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 right? 72 is not a perfect square. There's not a whole number times itself that would make 72. So if I want to answer as that decimal, would you have to round somewhere? That decimal goes on forever, right? Forever, ever, ever. It's about 8.5 something, I imagine, right? I do not want the decimal. I want to get the exact answer in what's called simplest radical form. Yeah.
I'm going to do 6 radical.
Okay, let's talk about how we're going to get that, though. The square root of 72 is not a whole number. It's a decimal. It's that decimal you got on your calculator just a second ago. That decimal, if you want to answer it in decimal form, would have to be rounded somewhere. It's not the exact answer. So to get the exact answer, think about which of these values I could use to factor into 72. In other words, which of these numbers divides into 72? 4 does. How many times does 4 divide into 72?
18.
Okay. Somebody else also said 36.
So now it'd be 9.
You can also do it like that, 36 and 2. Why couldn't you have just said 3 and 24? What's not great about these numbers, though? Are 3 and 24 perfect squares? So I have a hard time simplifying those. Look at these two options. Which one's preferable? The square root of 4 and the square root of 18, or the square root of 36 and the square root of 2? 36, right? Because if you choose 4 and 18, don't you still have more work to do on the 18? Aren't there other numbers from this list, namely 9, that you could keep factoring 18 with? Yeah, you can pick 4 and 18. You're just going to get to the right answer a little bit longer. It might take a little bit more work because you still have a number like 18 that you can divide perfect squares into. So let's get to the right answer as fast as possible by picking the largest perfect square. Square root of 36 and the square root of 2. Now, why did we choose the square root of 36? What is the square root of 36?
6.
When I start factoring these, I like to make sure that I put the square roots on them. Some people just bring down 6, 36, and 2. And they forget that they have to take the square root of 36 to start simplifying. I like to bring down the square roots when I start simplifying these radicals to let myself know how I'm going to work from there. The square root of 36 made 6. Square root of 2. That's not a perfect square. Can anything from this list, other than 1 obviously, divide into 2?
No.
No. 2 is prime. That's as far as we can go on the right branch of your factor tree. So to put this back together, it's plus or minus 6 square roots of 2. As a heads up, you know you have the simplest answer when the number inside the radical is as small as possible. I can't keep factoring the square root of 2 because other than 1, there are no perfect squares that divide into 2 again. Here's a couple to try. Square root of 54, square root of 98. Take a second and try simplifying those. If you haven't yet, in your notes, somewhere write down that list of perfect squares. If we're going to try and divide those numbers into 54. 2 and 27 divided into 54, but I wouldn't pick 2 and 27 because neither of those two numbers I can simplify as radicals. Awesome. Not very lucky for you.
So like, if this was on the test, I would like to
Some calculators do it. Some calculators don't. We still need to know why that answer makes sense, right? Because 9 times 6 makes 54, but the square root of 9 you make down to what? Seven divides into 98 14 times, but I wouldn't pick those because neither 14 or 7 are perfect squares. Think about what perfect squares divide into those two radicals. Start there. What you're not going to do is go to your calculator and give me the decimal. Do not want the decimal because it's not the exact number. I want to know what this is in radical form, not as a decimal. A few more seconds here, then we'll just kind of talk, make sure everyone's on the same page. Read how'd you factor 54? What pair of numbers can you break up 54 into? Take a look at this list. Everything from here divided into 54. 9, how many times? What's 54 divided by 9, in other words? All right. When you bring down 9 and 6, I highly suggest you put the radicals on them because I'm doing not 54, I'm doing the square root of 54 and factoring it. So its two factors are radical 9 and radical 6. We chose 9 because what is the square root of 9? Yes, 3. That's why you want to use perfect squares, because your goal is to find a number that you can simplify back into a whole value. The square root of 9 makes 3. 6. Yeah, you can keep factoring 6 into root 2 and root 3. But can you really do anything with those numbers? No. Is there anything from this list that would divide into 6? And obviously to divide into 6, it can't be bigger than 6. So all you have to work with would just be 4 and 1. You can't really pick 1 since it's not going to change it. Does anything divide into 6? No. So we're done here. Radical 6 looks good. Howard, how'd you try 98? Which factors did you pick for 98? 49 and 2. That looks good. I like 49, Hallie, because how'd you write the 49? What's the square root of 49? So 2's prime, so that's the other end of the branch on the right. I think we got it. Plus or minus 7 radical 2. Sounds fair. Let's try this one. Square root of negative 16. A square root should tell us what number times itself would make that value. What number times itself makes negative 16? What do you mean nothing? It's a negative. Oh, let's see. What number times itself would make negative 16? Why not 4 times 4? Makes positive 16. So why not negative 4 times negative 4? Also positive 16. Would I be correct in saying there's no number times itself? There's no real number times itself that would make a negative value. Yeah. We still need to be able to simplify these radicals. We're just going to have to use something called imaginary notation. Imaginary number. There's no real number that multiplies with itself that would make negative 16, because any number times itself has to always be positive. So use imaginary notation. We define imaginary numbers using the letter I. is for imaginary, and I is equal to square root of negative 1. I is equal to the square root of negative 1. So when I factor apart the square root of negative 16, let's do it in terms of I, in terms of the square root of negative 1. Negative 1 times what makes negative 16? 16. So don't you get back to a real number here? The square root of 16, we can obviously simplify. What's the square root of negative 1 equal to? Hint, hint, it's not actually a number, it's a letter. It's really what letter? It's I. We use I to denote all the imaginary numbers because square roots of negatives aren't real values, they're imaginary values. No number times itself can ever become negative. What's the square root of 16 again? 4. So wouldn't it just be equal to plus or minus 4? Square root of negative 16 is just positive and negative 4i. What's the square root of negative 25? If the square root of 25 is 5, what's the square root of negative 25?
Plus minus 5i.
Okay. What's the square root of negative 36? Whenever you see a negative inside the radical, eventually you're going to have the I in there somewhere, right? So just think of it as the square root of 36 in terms of I. The square root of negative 4 is 2i. The square root of negative 9 is 3i, and so on and so on and so on. A couple of these imaginary ones again. Square root of negative 12. Why do you know it's an imaginary number set? It's negative. So when I'm trying to simplify the square root of negative 12, let's break apart the imaginary part from the real part. I'm going to write down the square root of negative 1 and the square root of 12, because 12 times negative 1 gets back to negative 12 again. What's the square root of negative 1 simplified to? It's not a number, it's actually a letter, it's the letter I. So now the left side of the chapter tree is simplified. I've got that circled. Let's go worry about what's on the right. Square root of 12. It's not on this list, so it's not a perfect square. But what perfect square would divide into 12? That I can break it up into. 4 how many times? What'd you say, Austin? 3. Okay. I like how we didn't say 2 and 6 because 2 and 6 aren't perfect squares. It's best if you use these numbers because now I can simplify the square root of 4 into 2. Square root of 3 is prime. 3 is a prime number, so we're kind of done there too. Everything I've got circled, I want to put back together by multiplying for my answer here. I've got 2i radical 3. Some people like to put the 2i and then just leave the square root of 3 tail off the end, so it kind of looks similar to the 4i we had over here. You just have a square root hanging off on the end because 16 is a perfect square, 12 is not, so it's going to be in radical form still. You might also see it like this. It's the same thing. I times 2 radical 3. I like to put the two numerical parts together with the I out in front. That's the same thing. We'll write it like this. 2 square root of 3i. They put the two numerical parts, it's all the same thing, right? They're just multiplying, so I don't care the order. What it's not equal to is this. What's different about that? The i's under the radical, yeah? That's not the same thing. I like to put the I out in front. I like to put the I out in front so that I'm never going to be tempted to have the radical and the I underneath the roots.
What would it equal to if the I was under the radical?
2 square root of 3 times the square root of I. That's hard to give me like a decimal answer because this isn't a real number.
Or is that like is that how far is that?
It's the square root of the square root of -1.
I'm just wondering, like, is that like you can't simplify number then?
Not really. You guys try this one. The square roots of -32, please, right in the middle. Trevor, is that a real number or an imaginary number?
That is a real number.
Try again. What's inside the radical?
It's negative.
So is there a number times itself that can ever make a negative? It's imaginary. Right? There should be an I at some point in the final simplified version of that value. Where you want to put the I is kind of up to you. It's got to be in terms of I. This is imaginary value. Aren't there numbers that you can divide into 8 some more? You know you're fully done there, so when there's nothing else from this list that would divide into the radical that you got as part of your answer. However, I think I can still break it up into 4 and 2 with the 8 you had written down. Make the radical part as simplified as possible. So, well, the score to 8 comes forward. Are there numbers from this list that divide into 8 guys? You know you're done when that radical is as small as possible. You chose 4 and 8. They chose 16 and 2. You guys are really faster.
Are you sad because I think you read the
Doesn't matter. You get there eventually. It's all about it. Alright. We know it's an imaginary number, so let's pull apart the imaginary part from the real part. Square root of negative 1 is the I. Now let's come to the real value. Madison, how'd you break part 32? What numbers did you pick from the list of perfect squares?
16 and 2.
All right, 16 and 2 sound good. Did anyone do something else? 4 and 8, right? 4 and 8 are fine. You just have more work to do after you simplify the square root of 4 because there are still perfect squares that you can factor into 8. I like to pick the bigger radical, like 16 and 2 that she gave me, because I'm going to get to the final answer a lot quicker without the extra work. Square root of 16, Madison, would make what?
4.
4. Square root of 2, we're done. Everything I've got circled, we'll come back together for your simplified version. How about plus or minus 4i?